Okay, let's talk about AI agents. We throw around these very human-sounding words for them, right? We call them autonomous or self-managing. And look, it's a convenient shorthand, I get it. But it's also a metaphor that's hiding a pretty dangerous reality, especially if you're building systems that have to work in high-stakes, regulated industries.
And yeah, let's be absolutely crystal clear about this. This isn't just about picking the right words. Framing these things as autonomous actors is genuinely dangerous. It encourages this kind of hands-off attitude towards systems that absolutely demand rigorous, constant oversight. It basically sets your engineering teams up for failure by hiding where the real risks are lurking.
So, here's the question you've got to ask yourself. What are you actually building? Because if you think you're building an autonomous actor like you see on the left, what you're really engineering is a liability waiting to happen. But if you understand that you're building a bounded control loop over on the right, well, now you're creating a governed asset. That right there, that's the fundamental mindset shift we have to make.
To make that shift, we need to completely strip away the fluffy metaphor and just look at the machine underneath. Let's get right down to what an AI agent really is on a core technical level. It's actually way simpler and a lot more deterministic than all the hype would have you believe.
At its absolute heart, an agent is just a simple loop. That's it. It observes its environment, it generates some kind of output, it selects an action, it executes it, it observes what happened, and then it just repeats the whole process. Observe, generate, select, execute, repeat. That's the entire game.
And this right here is where all the trouble starts. Without explicit external limits, without any guardrails, this simple loop can just keep going and going and going. This is the critical difference between automation that's controlled and predictable and behavior that is dangerous and, well, runaway. And this is where a much bigger problem starts to emerge. This runaway potential leads directly to something called risk amplification. And trust me, it's as bad as it sounds. It's a phenomenon where one tiny little error in one cycle can cascade and grow into a massive, catastrophic failure over many loops.
So what's the fuel for this fire? It's the agent's state. Think of state as everything the agent is accumulating over time. Its memory, its own past actions, responses it's gotten from other systems. So for example, if an agent wrongly flags a transaction as suspicious, boom, that error is now part of its state. Future decisions are now being based on that faulty memory. And the scary part is, this state can drift, causing the agent's behavior to change in really unpredictable ways, all without a single line of code ever being altered.
This brings us right to the core concept of failure amplification. Just imagine this for a second. An agent misclassifies one tiny piece of data. Okay, no big deal, right? Wrong. In the next loop, it makes a new decision based on that first error. And in the loop after that, it acts on the result of that faulty decision. You see? The error doesn't just stick around, it gets amplified with every single iteration.
And, this leads to some pretty common and pretty nasty failure patterns. Letting the agent just iterate forever, accidentally letting it escalate its own permissions, losing track of that hidden state we just talked about, or having a human in the loop who just rubber stamps whatever the agent says. But let's be clear, these aren't some kind of weird, exotic AI problems. Nope. These are classic, old-school system design and engineering problems.
So if these are engineering problems, then guess what? They require an engineering solution. Control isn't a nice-to-have feature you can just bolt on at the end. No way. It's a non-negotiable, foundational piece of the entire architecture. We have to engineer safety in from the very beginning, using explicit boundaries.
Which of course leads to the big question. How do we actually do that? How do we design a system that enforces control and makes these runaway scenarios just impossible by design?
Well, the solution comes from a tried-and-true concept in IT and operations, the control plane architecture. The whole idea is the separation of concerns. You see, down in the execution plane, the AI services and workflows, they do the actual work, but everything is governed by the control plane sitting on top of it, which handles policy, validation, approvals, the important stuff. The two are fundamentally and purposefully separate.
Let's just boil that whole diagram down to its absolute essence. It's this simple. The agent's job is only to propose actions. It says, hey, based on what I see, I think we should do X. The control plane's job is totally separate. It acts like a gatekeeper and decides if that action is allowed. If your agent can both propose and execute, you've basically built a rogue operator inside your system. This separation isn't a suggestion, it's mandatory.
So what does that control plane actually control? Well, it enforces hard limits across a bunch of different dimensions. The number of loops, how long it's allowed to run, the exact actions it can take, the permissions it has. Every single one of these boundaries must be enforced by the control plane, not by the agent. You never, ever, ever trust the agent to limit itself.
All right, let's bring all of this together into a final set of clear, actionable principles. Think of this as the mandate for any team that wants to design a safe, governable agent system, especially in a regulated environment. Here it is. Here is your checklist. You need explicit bounds that are enforced externally. You need state that is visible and that you can reset. You absolutely must have that separation between the agent and the control plane. Every single decision must be auditable. And you have to design and actually test your stop conditions for when things go wrong. If you're missing any one of these, your system is unsafe.
Now, just to be super clear about what we've done in this explainer, what we've done is explain the core mechanics and the risks to help you and your teams with responsible design. What we have not done is recommend a specific framework or, approve any system for deployment. This is all about giving you the right mental model so you can go and build safely.
And so we end right back where we started, with a direct question for you to take back to your team. Look at your architecture, look at your design philosophy, and ask yourselves honestly, are you designing liabilities or are you engineering governed assets? The choice of framework you use matters way, way less than the answer to that one question.